Okay, so I'm going to do another example where we are going to be given a function. We're looking at the critical points, the first derivative sign chart, the max, min, and then concavity using the second derivative sign chart. So the first part says identify the critical points. So again, for critical points, we always find the first derivative and we set it equal to 0. So my first derivative is 5x to the fourth minus 5 times 4 is 20x cubed. The derivative of 8 is 0, so I don't need that. I'm going to set this equal to 0. So I have to factor. The GCF would be 5x cubed. And then if I divide this by 5x cubed, I would be left with an x minus 20x cubed divided by 5x cubed would just be a 4. And then I'm going to set 5x equal to 0 and x minus 4 equal to 0. I have to set any part that has a variable in it equal to 0. So this first one, I divide both sides by 5 and I get x equals 0. The second one, I add 4 and I get x equals 4. So these are my two critical points. B says determine using a first derivative sign chart intervals on which the function increases or decreases. So again, it's completely up to you if you want to make the table or if you want to just do kind of the more basic sign chart. Either way is fine. I'm just going to do the basic one because it's a little bit faster, but either way, it doesn't matter. So for this one, I put F prime and F. I put my critical points. So this is 0, 4. And even for this, if you want to like put the intervals below to show what the intervals are, you could. So this like divides it into 3 intervals. The first one is anything less than 0. So it's negative infinity to 0. The second one is between 0 and 4. So that's this interval. And the third one is anything greater than 4. So that's 4 to infinity. So then I'm going to do test points. So I plug numbers into the first derivative in each interval. So this first interval from negative infinity to 0, I'm going to plug -1. And again, you can either use the calculator and type it into y equals. So I type in 5x and then use that caret to get to the exponent, 4 minus 20x and then cubed. And then if you didn't change it, you'd have to go to second window and then go to independent and change it to ask. But if you already did that, you shouldn't have to do that. And you can just go to second graph to get the table. And then you would type in -1 here to get the number, which is 25. Or you can plug it in and calculate it into either this one or this one. Or kind of if you're like good at mental math quickly, you can always just think, okay, I'm doing 5 times -1 cubed. So a -1 cubed is a negative. A negative times a positive is a negative. So if I do it this way, I often write it like this. I'd have like a negative, and then I would do -1 minus 4, which is also a negative, and then a negative times a negative is a positive. So if you don't want to find the exact value, you can do that as well. You need to just indicate the sign. So because I got the derivative of -1 to be 0, I'm going to put, or sorry, to be positive 25, I'm going to put a plus here. And then F is increasing. I'm going to then try a test point between 0 and 4. So any number between 0 and 4. So I'm just going to do 1. And then again, you can either go to your calculator and just type in 1 and hit enter, and it will give you the Y value. Or you can plug it into one of these and just figure out the sign. But I get a negative, so I'm going to put a negative here. If F prime is negative, my original function is decreasing. I have one more interval, 4 to infinity, so I'm going to plug in some number between 4 4 and infinity, so something bigger than 4. So let's try 5. Again, I'm just going to use the calculator and type in 5 and hit enter, and I get 625, so it's positive. The main thing with this, because there's so many different functions, is make sure you're using one of the first derivatives, either the factored form or the original. And then because it's positive, I have it increasing. I just indicate here, because it's increasing and then decreasing, I have a max. And here, because I'm decreasing and then increasing, I have a min. So at x equals 0, I have a max, and x equals 4, I have a min. And then I would just write out, okay, I'm increasing from negative infinity to 0, union 4 to infinity, because those were the two places that I'm increasing. And then I would be decreasing from 0 to 4. And then it says classify the critical points as max, min, or neither. Again, I'm going to find the y value for this part and then write the points as max or mins. So the two places I have max and mins, let me put zeros because that's where the first derivative is 0, is at x equals 0 and x equals 4. To get the y value, I plug it into the original function, this function. And you could do the same thing in your calculator. You could type then in this function into y1 and use your table and ask for 0 and then find out what it is. But I'll just calculate this by hand. This one is going to give you 8. So my point is 0, 8. And we found at 0 we have a max. And then I'm going to plug in 4 to that. And calculate that. And I get negative 248. And we said that one, so that point 4, negative 248, as we said at x equals 4 is a min. And so that's all the first derivative stuff. D says determine using a second derivative sign chart intervals on which the function is concave up and concave down. Concavity is always determined by the second derivative. So you first need to find the second derivative. Okay, when you're doing that, always use the non-factored form so that you don't have to do a product rule. So the derivative of 5x to the 4th is 20x cubed. The derivative of negative 20x cubed is a minus 60x squared. When I'm doing a second derivative sign chart, I set the second derivative equal to 0. I factor, so the GCF is 20x squared, and I would get x minus 60 divided by 20 is 3, and the x squared cancels, so x minus 3. Set each one equal to 0. So this one I'm going to divide by 20. I get x squared equals 0. And then to get rid of a squared, I take the square root. Now, usually we should have plus or minus when I take a square root, but because it's 0 and 0 doesn't have a sign, we just have 0. And then I would add 3 on this one, and I get x equals 3. So again, especially this one doesn't have a lot of room. You can do either of the tables, but on this one, again, I'm just going to do the number line. And I put these two numbers in order from left to right. So I'm going to put 0, 3. I'm going to put f double prime because I'm looking at the second derivative, but I still put f because I want to see what's happening with the original function. We found that it's 0 at these 2 points. And then I have to try numbers in each interval. So again, this lowest interval is anything less than 0, so it's negative infinity to 0. This interval is between 0 and 3. And then this interval here is anything greater than 3. So if you want to put the intervals below, you can. You don't have to, but you need to write them out when you're answering where it's concave down and concave up. Okay, so we do a test point in each interval and plug it into the second derivative. And I need 3 test points because I have 3 different intervals. So my first interval is anything less than 0, so I'm going to plug -1. Again, just to save time, I'm going to go back to my calculator to y equals, change y1 to my second derivative, so 20x cubed minus 60x. Sorry, I always put the -1 instead of the squared. X squared there we go. I'm going to go to second graph to pull up my table, and then I'm just going to plug in my 3 numbers. So let's see, my interval should be, the first one is less than 0, so -1. The second one is between 0 and 3, so let's say 1. And the third one is anything bigger than 3, so let's say 4. And I wrote those out so I can just do these all at the same time. So I would type in -1 and hit enter, and I get -80. I already have 1 in, but I type 1, enter, and I get -40. And then I would type 4, enter, and I get 320. So at -1, I get a negative. Okay, at 1, I still get a negative. And at 4, I get a positive. Okay, so I have negative, negative, positive. Good. If my second derivative is negative, my original function is concave down. Again, negative, so concave down, positive, so concave up. So 0 is not a point of inflection. It doesn't change concavity. My only inflection point, is at x equals 3. So for my intervals, and I don't have a ton of room. They didn't give us a lot of room for this problem. I would say kind of over here, concave up from 3 to infinity. And I would say down, I have to put both intervals negative infinity to 0 union 0 to infinity. Sorry, 0 to 3. You can't say negative infinity to 3 because at 0, the second derivative was 0, so it's not really concave up or down. So the inflection point occurs at x equals 3. I want to find the y value by, again, plugging it into the original function, which was x to the 5th minus 5x to the 4th plus 8. So I would have 3 to the 5th minus 5 times 3 to the 4th plus 8. Gives me negative 154. Okay, so my inflection point is 3, negative 154. Then I'm going to use this information to graph it. This scale is not really helpful because my points go down to like negative 248, negative 154. So let's change this to like negative 200 instead to make it easier to graph. So the first thing I'm going to do is graph all the points that I know and then use the rest of the information to connect them. Okay, so the points we found, let's see, we found 0, 8 is a max. I guess to make this scale equal, we'll say this is 200 again. So 0, 8 is going to be like really low. I guess this would be 100, so 50. So it's going to be like really low here. We're not going to have perfect here. So I'm just going to mark it to indicate what it is because it's hard to tell because I'm going to do a rough scale. So that would be my 0.08, which I know has to be a max. So I don't want to go above this point when I'm close to it. We know 4, negative 248. Okay. So 1, 2, 3, 4, negative 248. So that's going to be somewhere around here. Again, because I don't have a perfect scale, please make sure you label your points if you're doing something like this where it's not obvious where they are. And this, it should be a min, a relative min. And then we know that our point of inflection is at 3, negative 154, which is going to be somewhere around here. Okay. So just to keep in mind, if I draw my sign charts quickly here so that they're closer. For my first derivative sign chart, we had 0 and 4. Okay, and this was my second derivative sign chart. If I'm just writing it so I have it by my graph. Okay, so for 0, I'm increasing till I get 0 and I'm concave down. So I'm going to start below it because I'm increasing and I'm going to do my best to be curved down and come up to it. And then this is the highest part. So I have to start going down and I still need to be concave down until I get to 3. So I'm going to still be as best as I can curved down. I'm going to make this a little better. Curve down and then concave down until I get to this point of inflection. And then I'm going to do my best to curve up, but still I'm going down until I hit this point. And like I said, it's sometimes really hard to see it. Sorry. So this I would write like PI next to it and put like down here to indicate, and then like up here just to explain that it's changing because this isn't the best. And then after 4, I'm increasing and I stay concave up the rest of the way. So I'm just going to go curved up and then show increasing. And this is a rough sketch of what my graph would look like. So that's another example. Okay. And again, whether you do a sign chart like I did here, or if you're more comfortable doing like this type of chart, that's fine as well. Either one is fine. Just make sure for your sign charts that you have somehow indicate the intervals either in a number line or writing them out, and then showing what happened with the second derivative and the original function if it's a second derivative sign chart. Or if it's a first derivative sign chart, then you should be showing the relationship between the first derivative and f. Okay, so that is the second example of how to do these problems. And then I'm going to do another video with another example.